Welcome back. This video here looking at one, properties of ionic compounds, and two, just kind of what makes an ionic compound an ionic compound. So first thing, to make an ionic compound, first you need things to bond together. So keyword here is electrostatic attraction. So an ionic bond is an electrostatic attraction between oppositely charged ions. So when you get a positive and you get a negative, there's your charges. That's where we get the electrostatic part. So we have these oppositely charged things, they stick together. So when that electron is transferred from the metal to the non-metal, that's what gets us our charges, and that's what sticks them together. So again, for an ionic bond, the electrons are taken, not shared, which we'll talk about later. So those electrons are transferred or taken. Ionic compounds composed of both cations and anions, again usually metals and nonmetals. We do have those polyatomics though, which are present in the form of ions. So again, you had to have lost or gained electrons for this to work. And then even though we do have some positives and some negatives, always neutral. And they always combine in that proper ratio to become neutral to get that charge of 0. Just showing you a little more from that. So for magnesium fluoride, so what happens there as well? Magnesium gives one of its electrons to this fluorine, gives the other electron to this fluorine. You now have a 2 positive with 2 1 minus charges, like it shows here, come together, form that magnesium fluoride ionic compound right there. So metal, non-metal, had our charges come together, form something neutral. Alright, so properties of ionic compounds. Well, the first one is that ionic compounds have crystal structures. So they form these nice, pretty, perfectly arranged structures. So this is table salt, a very common ionic compound. We're going to use it a lot for what you see here today. But notice how everything is arranged. Remember from our ionic trends, or from our periodic trends, that anions are bigger than cations. So the NAs are the little blues, and the Cl's are the big green ones. They get this nice, perfectly ordered, perfectly arranged structure there, and with in this case, 1-to-1 ratio. So for every 1 green, we have 1 blue. Just to kind of compare this to something, so something like glass is not an ionic compound. So if you look at the structure of glass, notice how it's not perfectly arranged. You know, some are closer than others. So this is what we would call amorphous. This is what we would call crystal, or crystalline. So you don't need to know this structure of glass, but just to kind of give you kind of the counterpoint to this. The other property of ionic compounds is that they have high melting and freezing points. What this means for you is that ionic compounds are, is it going to let me write or not? What it means for you is that they are usually solids. Oh my gosh. So if we look here, think about table salt. Have you ever seen it when it's not a solid? In the back of the stock room, I have a ton of ionic compounds. Every single one of them is a solid. That's because, if we look here, this attraction is so strong, is so tight, that to break that and get them into a liquid where they're not as close together takes a lot of energy, takes a lot of heat. You need a really high temp. So just to kind of give you some comparison, water, melting point is 0 degrees Celsius. That was the boiling point. The melting point for gasoline, -57 degrees Celsius. For oxygen that we breathe, -208. So these are all molecular compounds, or in this case just an element. But sodium chloride, our ionic, has a high melting point. And that's what makes it a solid. So to get it to go from a solid to a liquid, you got to heat it up to 801 degrees Celsius. That's pretty high. The other one is that ionic compounds are electrically conductive when in water. So if you dissolve salt in water and hook it up to a battery, it would complete the circuit and the light bulb would light up. If you just had plain water without the salt, and not tap water, but distilled water, so it's nothing but H2O, notice hook up a battery with a light bulb, the circuit doesn't complete. So these two electrodes aren't touching. There's nothing to transfer the charge from one to the other. It doesn't light up. Same thing here. If I had something like sugar water, sugar is not an ionic compound. It is molecular. Same, you can't see it here, but the electrodes aren't touching. Nothing can transfer that charge from one of the posts to the other ones, so it doesn't light up either. So again, with our salt, electrodes not touching, but yet something is still allowing the charge to move from one to the other, and that's those ions. Those positive and negative ions are floating around there, act just like the electrons in the metal here. They transfer from one to the next, lights the light bulb. So your third property, that they are electrically conductive when dissolved. And the last one, these crystals, they're brittle. So when you strike them, so if I cause stress on one of these or stress on the other one, look what happens to the ions. So they were perfectly arranged, but then I get, I have two positives and two negatives and they're lined up. Well, now they repel each other instead of being attracted. That breaks them apart. So then they repel and breaks them apart. This is what causes them to shatter and break into a bunch of pieces. We also call that brittle. Instead of just bending. As soon as we start moving the structure around, we can get repulsion. That's going to break the structure. So those are your four properties of ionic compounds, just for review. They have crystal structures. They have high melting and freezing points. They are electrically conductive when dissolved or melted. If you were to heat sodium chloride up to over that 800 degrees Celsius mark, it would be electrically conductive there as well. And the other one is that they are brittle. So just a review. Why is this an ionic bond? Well, that electron is being transferred. We get that positive and negative charge. Which element loses the electron? Well, think, okay, which one's the metal? So this guy's the metal. He's going to lose it. Why? That's going to complete his octet. So when this electron is gone, it's no longer there. It's now in the next inner circle that's full. What is the number of ions of each element? In this case, it's 1 to 1. Think about your charges. Na plus, Cl minus. They're equal, so they go together 1 to 1. Charge on the Cl, well, it gained that extra electron. It was the minus. Next question, why do these attract? Well, they're oppositely charged. Opposites attract. The attraction between two ions that results from a transfer of electrons is called hey, that sounds like a test question if I've ever heard one. This is an ionic bond. And then last one here, why are these stable? Again, full octets. So this guy has 8, he's happy. This guy has 8, he's happy. That's the whole idea of gaining and losing, to fulfill that octet rule. Last question here, which of these compounds represent ionic bonds? So again, I got to think, what makes an ionic compound? Well, I need a metal and a non-metal. So all of these that you do not see a metal for are not ionic. So this one, well, I see a metal here, so that one's 1. This one, I don't see a metal. This one, I don't see a metal. This one, there's a metal. There's a metal. There's a metal. Nope, no metal there. There's a metal. There's a metal. So those that are underlined have ionic bonds or are ionic compounds. Match each set with the correct name. All right. So Na, that's sodium. Well, I only have one of those, so there's C. The next one, MgSO3, I got to be careful because I got a 3 here and a 4 here. So 3 would be sulfite. That's A. That means this one has to be B. Next one down, all calcium, so there isn't an easy one. I got to look here. HCO3, I check my cheat sheet, that's called bicarbonate. So that one is C. The next one, CO3, there's my polyatomic, check my cheat sheet, that one's called carbonate. Okay, same as before. Just to double check the last one, PO4, yep, that's phosphate. And that's all I have for you. Make sure you double check those properties, what makes ionic bonds, stuff like that. That is what you need to know.